Paula the painter and her two helpers each paint at constant but different rates. They always start at 8 a.m., and all three always take the same amount of time to eat lunch. On Monday, the three of them painted 50% of a house, quitting at 4 p.m. On Tuesday, when Paula wasn't there, the two helpers painted 24% of the house and quit at 2:12 p.m. On Wednesday, Paula worked by herself and finished the house by working until 7:12 p.m. How long in minutes was each day's lunch break? Here there are multiple variables that we have to set. Let's first write out the information that we know in columns in an organized fashion, so then based off of that, we can write out the equations using the variables. So here is what happened on Monday. This is what happened on Monday. So they start at 8 p.m., 8 a.m., and then they go all the way until 4 p.m. So they were working for a total of 8 hours. They got 50% done. On Tuesday, when it was just the helpers, they started from 8 a.m. all the way to 2:12, and they got 24% done. When Paula was working just by herself on Wednesday, she was able to get 26% done, working from 8 all the way to 7:12. 26% done, and then they were able to finish the house. Now, based off of this, which variables do you think we should set? Well, I think based off of this, we could write one equation to describe each of these days, meaning that there will be 3 equations total, which means that the maximum amount of variables we can have is the maximum amount of variables we can have is 3 variables. Let's let the length of the lunch break as L. So L is equal to lunch break time. And then we still have to set the rates that Paula and her workers work at. So Paula we can set as P. P represents rate of Paula, how fast, how efficient she works. And since her helpers are working at the same amount, the same rate, then the workers would be rate of workers, and this will be the 2 workers combined, because throughout the problem, the 2 workers are never apart. So now is when we can write out the system of equations. I'm going to move this over so we have more room. So how can we describe Monday? We know that the total amount that they got done in the end was 50%. But since they're all percents, I'll just ignore the denominator and just write the percentage that they finished. So the first day they completed 50. Remember, this is we need to use our formula D is equal to speed times time. Here, distance is not exactly how long something is or how far something is. It's just the total amount of work that was done. So 50 is a total here. And now what was the time? How long in total did they work for? Well, they worked from 8 a.m. to 4 p.m. That would be 8 hours. And then subtracting the lunch break where they did not work, that would be 8 minus L for the time, multiplied by their efficiency, which would be all 3 of them. Remember, on Monday, all 3 of them were working together. So that would be the rate of Paula, P, plus both of her workers, which are W. That would be our first equation. What about our second equation? We know that the 2 workers completed 24%, so that would be the total of Tuesday. And how long did they work for? They worked for a total of 6.2 hours, and we can subtract L, which is the lunch break, times workers times W. That is equal to 24. So this is our second equation. Now finally, we need to have an equation that describes Wednesday. How long did Paula work by herself from 8 a.m. to 7:12? Well, she worked for 11.2 hours on that day, minus the lunch break, which is L, times P, which is her own working efficiency. She was able to get 26% done just by herself. This is our third equation. So this is our system of equations. Now we have to solve for L. Here we see that the sum of the first equation is 50, and that would be the same if we added 24 and 26 together. In order to have as many equivalent relationships as possible, let's add equations 2 and 3, and we have 6.2w plus 11.2p minus L times p plus w is equal to 50. Now, in order to cancel out this 50, we can subtract the first equation from this. That'll give us negative 1.8h plus 3.2p is equal to 0. Negative 1.8w plus 3.2p is equal to 0. Therefore, the equivalent relationship we get from this after simplifying is that w, the rate of the two workers combined, is equal to 16/9 times the rate that Paula works at. So now that we have this, you could just substitute it back into the previous equations and solve. Now that entire process I'm not going to cover, but because I'm pretty sure that you guys know how to do that by now. But the main point of this is to organize all your information like this, set the correct variables based on how many equations you have, because when you set variables, you have to be mindful. If I only have 3 equations, I can't be setting more than 3 variables that I need. So and then after getting the different equations that you need, you can try to find equivalent relationships among them. For example, spotting and noticing that 24 plus 26 can combine to equal 50, and then so on. So your answer after substituting should be that the lunch break is 48 minutes. So L is equal to 48 minutes, and this is your final answer.